Slope failure, when a slope collapses due to weakened self-retainability of the Earth. There are various types of slope failure, such as landslides, mudslides, rock slides, and debris flows, all of which involve downhill movement of material which occurs on unstable slopes. The mudslide in particular involves the downhill movement of mud or other earthy materials. There are various factors that make a slope unstable. They can be categorized into acts of nature and acts of mankind. A few examples of acts of nature are as follows. Steepness of the slope, as it goes without saying that the steeper the slopes, the more unstable it will be. Water and drainage, as water being heavier than air saturates the earth, increasing its mass. As saturation also allows the earth to move downhill more easily. Rainfall. Seismic activity, which may trigger or dislodge the soil, allowing the slope to fail. Vegetation, or lack thereof, keeping the slope stable with the roots. Soil management and composition. Loose soil and or sand will shift easily, whereas soil with plenty of clay is more prone to water saturation, meaning that it can become heavier and thus less stable. Erosion, causing the landslide to wear away gradually. A few examples of acts of mankind are as follows. Direct infiltration, improper excavation, additional weight such as inadequate or improper construction of housing. Houses built on a slope will exert a downward pressure on the slope, once again reducing its stability, blocking drainage channels resulting in an overflow of surface water, and so on. Slope failure can occur at any time, with hardly any warning. However, heavy rainfall does increase the chances of one occurring. This would mean the chances of a slope failure are higher during a country's monsoon season if there is one. An example of heavy rainfall influencing a landslide is Hong Kong's 1972 Po Shan Road landslide, in which the landslide knocked down a 12-story building. On the 22nd of March 2014, a devastating mudslide occurred east of Oslo, Washington. It was the second deadliest landslide in recorded US history ever occurring, resulting in 41 deaths with 2 people still missing. It occurred at the southeastern edge of Whitman Bench, 240 meters above the valley floor in an area known as Slope Hill due to its history of slope failure. For the past 80 years, landslides have been occurring here every decade or so. The slope consisted of gravel and sand deposited during the most recent glaciation. Nearly 50 structures were destroyed, along with the 41 deaths, 4 being severely injured and 2 missing peoples. The disaster was caused by recent heavy rain and the groundwater saturation from over the past month. However, it is questioned as to what mitigative methods were used, as this land is well known for its history and landslides. According to Ken Armstrong, investigative reporter for the Seattle Times, it gave way in 1949, in 51, in 67, in 88, and in 2006. This 2014 Oslo mudslide is said to be a reactivation of the 2006 Steelhead landslide. In 2006, officials had planned to move the river's flow 430 feet to the south. This was based off a report written by Seattle engineering firm William D. Shannon and Associates, which said one possibility to control the slides would be to divert the flow of the river which the mountain was sliding into. In the same report, Shannon suggested building berms, flat, raised strips of land, and to also reinforce the unstable toe of the slope that was allowing it to fail. Crews worked on installing a crib wall made of boom logs during the summer of 2006. These were anchored with 9,000-pound concrete blocks every 50 feet and were supposed to prevent sediment washing into the river. However, homes were still built in the range of the slope, and apparently, according to Pat Stevenson, environmental manager of the Stillaguamish tribe, county officials who approved development seemed more focused on whether the homes were in flood areas than on the risk of a landslide. This could possibly be one of the reasons that allowed people to remain occupying the area affected by Slope Hill. As with most natural disasters, there is always post-event work to be done. For the Oslo mudslide, the media has documented the event very well despite the ongoing search for the remaining 2 missing people. The documentation can be analyzed by scientists to help understand the motion and mechanics behind the mudslide. This can help improve the prediction of the risk in the same or other locations. Aside from understanding the physics, the tragic stories of the Oslo locals are taken and transformed into official case studies and hard data, allowing scientists to further analyze and reflect on the disaster. All this information is then passed on to engineers who will be working with this area in the future so they have a better understanding of how to mitigate against slope failure.
I was on my way to pick up my kids from their mom's house for the weekend, and basically I saw a truck and a boat driving towards Darrington too, and I was 3 cars behind of this truck and a boat, and then I just saw the darkness covering the road, like something unusual.
The economic development of a country plays a crucial part in its mitigation and response to hazards. As shown on the graph, In a more economically developed country, EMDC, when a hazard occurs, the quality of life, economic activity, and social stability decreases suddenly. But gradually, the damages are repaired, and improvements for mitigation and preventive measures are made. By the end of the year, the quality of life, economic activity, and social stability will be normalized, or possibly even better than the normal conditions before the hazard occurred. On the other hand, economically less developed countries, ELDCs, find it harder to normalize their quality of life, social stability, and economic activity after a hazard occurs. Even after repairs are made, no further improvements are made, and the society's conditions may be worse than what it was like before the hazard occurred. The reason for this is because EMDCs have more resources and support to normalize their situation, whereas an ELDC starts and ends with less resources, making it harder for them to get back on their feet. A quick 10-second landslide has disastrous impacts on the society. The deaths, injuries, houses, structures that were destroyed, and the roads that were blocked caused by the devastating mudslide in Oso have significantly impacted the community. There may be a decline in economic development in the country because of costs of replacement, repair, and maintenance. Properties devalued as a result of the landslide may lead to a loss of tax revenues. Moreover, human or domestic animal productivity may be diminished because of death, injuries, or psychological trauma. There may be a loss of industrial, agricultural, and forest productivity, and of tourist revenues because of the damage to land or facilities or interruption of transportation systems. Over a quarter of the population of the small town was killed or injured. The mudslide also destroyed a total of 49 buildings and structures. 25 of them were occupied at the time of the mudslide. The community was impacted immensely as many fathers, mothers, babies, loved ones, and homes were lost. This disaster has prompted the federal government to do better in the future and make sure no unnecessary disasters have to happen.
New slopes that belong to both private and public developments are regularly checked, and governments are upgraded and maintained. Squatters on hilly terrains are cleared in order to carry out landslide preventive measure works on their slopes. The government also organizes many activities to educate the public about slope safety, the importance of slope maintenance, and the responsibilities of privately owned slopes. The government also implemented a landslide prevention and mitigation program in 2010 after some detrimental landslides occurred. The main aim of this program is to reduce the landslide risks in Hong Kong by upgrading all man-made slopes and carrying out mitigation works on some natural hills-like catchments with known hazards that are relatively near buildings or transport corridors, because extensive slope stabilization works on natural hillsides are carried out because of the high cost and damage to the environment. Some examples of the mitigation measures include the boulder fence in mid-levels, the debris barrier in Lung King, and the steel flexible barrier in Tung Wan. Hong Kong has used several other methods to mitigate the effects of landslides. These include the aforementioned barriers and several cement anchors placed on mountain slopes. The anchors are very basically long poles with giant cement blocks at the end. The people that put the anchor into the mountain have to analyze the surrounding area. The land is stable enough to put the anchor in. If the anchor is really necessary, the soil quality, depth of the hole needed, and that among other things. The anchors work by being screwed into the mountain, down into the bedrock. At the end of the pole, there is a mechanism which expands and keeps the whole mountain together. The mechanism is also in the middle of the pole to help keep the earth closer to the surface stable, as that has a higher risk of failure. The cement block at the end acts as a weight to keep everything still and to hold it together. Another way that Hong Kong has used to mitigate landslides is by using drainage pipes. They work by simply allowing runoff water to flow into the drain, preventing water from going in between cracks of loose earth and dislodging them.
In conclusion, landslides are inevitable, but because of the advancement of technology, the impacts of the hazard are better mitigated in society nowadays. However, the Oso mudslide was a disaster that did not have to happen. The society should have better mitigated for this event by just simply disallowing homes to be built in that area to remove the risk of human lives and property.